Hello, this is a tutorial of JavaScript, how to make a Mandelbrot set in JavaScript. It's a really simple program, and this is it. So we go on to js.doo for JavaScript programming mainframe stuff. This is js.do, JavaScript program there. And as you can see at the top, it says script in meta tags. I'll just delete all this, copy and paste. Yeah, and go down to /script and delete all this at the end. Okay, let's run code and let's see a blank screen. We have to declare a variable. We declare a variable var space z equals 0 and var space c equals 0. And var z new equals 0. I'll just save that for later. What we got is the Mandelbrot set is z equals z squared plus c. What we do is z equals, you got to do math dot pow math power. Z equals z squared, comma 2 for squared, and then plus c. And then x plus I is imaginary number. We'll just put that in rem, little message. X plus iy squared brackets equals x squared minus y squared, because iy times iy, I is square root minus 1, so square root minus 1 times square root minus 1 equals minus 1, so it's x squared minus y squared. And the imaginary part is plus 2xy 2I times xy. Okay, that's 2 backslashes make a rem statement. The program ignores that. Okay, so now we'll declare x new equals x old squared. So we go math dot power brackets x old squared, comma 2 squared, minus math dot pow y old, comma 2, and that's x new equals x old squared minus y old squared. Let's see what we wrote down in the message that the program knows there. And then y new equals what's imaginary axis, which is the y-axis. So what we wrote there was plus 2i xy. So it's 2 times x old times y old. Now we have to find out the this is the x new and y new coordinate. And by Pythagoras theorem, let's say r new with the radius new in the complex plane. And by Pythagoras theorem, r new squared equals x new squared plus y new squared. By Pythagoras, hypotenuse squared equals length of side squared plus length of the other side squared. So take the square root of both sides. R new equals maths dot power all of that, 2 brackets, bracket there, comma, 0.5, which is a square root. Or you could say 1 over 2, same as 0.5, which is a square root. Something to the power of a half is a square root. Well, R new is the radius in the complex plane. Well, R new is less than bailout variable, or less than equals to bailout variable. And then we put these curly brackets to encase the loop. And we'll put it all in there, put bracket at the end, so that's while loop, there to there, where the brackets, curly brackets are. And then we'll say iter, as in iteration. Iteration equals iteration plus 1. And we'll declare the variable. You've got to declare the variables. Variable iter equals 0. And then we go checking if at that line iter equals iteration, it means it's a iter equals iter plus 1. So it's adding 1 every step of the loop. And if we go if brackets iter is greater than or equal to, say, 100 iterations, brackets, then curly brackets, encase that loop. If the iteration is greater than or equal to 100, then we want to do a little message here, then plot black Mandelbrot lake. So just we go something I prepared earlier. I've forgotten half the commands, but with practice, you can make a few programs. And got a few graphics programs here, something like this, something I prepared earlier, which plots points, and the graphics part is here. It says context begin path, context arc, context stroke style to make little circles, tiny circle. So get this part, copy it here, copy, put it back here. So if it's equals 100, we want to plot the x and y point. So we paste it there, CTRL and V, and this context begin path is here. Context arc makes a circle. Okay, got to define center x now. We get the center x from this program here. You see at the top it says canvas, so we can copy the paste the style and body, all this junk kind of coding here. I think canvas will do it. Just copy canvas to here for script or the header code to set up the canvas of width 1728 by 972, and says variable canvas equals document get element by ID my canvas, and canvas gets on 2D to set it up. Copy these few lines since I've forgotten half the commands. Save a bit of time, copy and pasting from previous graphics programs. So it's a canvas routine. It says center x, it was canvas width divided by 2 was the center. And this is what it says down here. Center x. So what should we do? Let's try this. We put in center x plus x old. Now the Mandelbrot set is about 2 pixels by 1.5 pixels approximately. So you've got to multiply x old, let's say times 100 pixels, and then comma center y plus y old times 100. That says context line width 1 pixel. Context stroke, so we'll just put a little slash comma black slash comma there. We'll delete this junk code off here. Okay. So we say if iter is greater than 100. Oh, I've done the curly brackets there. And what we've got to do is do a loop through all the pixels. So we go for brackets xp equals minus 100 colon xp is less than symbol less than 200 positive 100 colon xp plus plus, which adds on xp increment by 1 curly brackets. Put all that in a loop. Put a curly bracket down here at the end of the program and do for yp equals minus 100 yp is less than 100 yp plus brackets and curly brackets to make a loop and close curly brackets down there in the program. Now just put that on 2 backslashes the message the program will know. So now that line. Now the pixel in the Mandelbrot set is about 1 pixels by 1.5 pixels or 2 pixels approximately. So we went minus 100 to a plus 100. We'll say Cx equals xp divided by 20 and y cy equals yp divided by 20 in the Mandelbrot set range. Let's see this. We've got to add c on this line plus c x for x new, and the next line plus cy. And not to forget to declare our variables, the rest of the program won't work. Hence variable xp equals 0, variable yp equals 0, and variable cx equals 0, variable cy equals 0. Let's see if this works. But don't forget to save your program on JS. Just we'll call it Mandel test. Description Mandel basic setup, and then you go save. Yeah, your code has been saved, just in case it crashes. Okay, run code. It says new is not defined. There's a reference error up here on line 23. Yeah, we didn't clear it very well. New variable new equals 0. Bailout. Oh yeah, we didn't declare bailout. Yeah, the bailout. Just put a VAR space bailout in there. Bailout equals 4 is usually the one code. XOL is not declared. Reference error there. VAR XOL equals 0. VAR YO equals 0. Okay. It's not doing it. Okay, it could be this. I don't know. Let's see. Copy that. Let's see black. So no, it's not that. Oh, we haven't declared x new and y new variables. So we put in var x new equals 0, var y new equals 0. See if that works. No. Oh, we didn't set iteration to equal 0 because it keeps adding up. It's got reset to 0. We will try again. No. It's this line 34. On you. You got to do math power. You can't do squares like that. It's got to be math dot power x new comma 2 brackets plus math dot power y new power 2. See if that's any better. Still doesn't work. Could be this line. R new equals math power. You've got to do math dot power of x new comma 2 to make it squared. You can't just go squared like that. JavaScript doesn't understand it. You've got to go math dot power. I get y new comma 2. That's in brackets, that's in brackets, that's in brackets. Save that now. Okay. Okay, there's a bit of error there. I don't know why it isn't working. We'll just delete that off and delete that off. We'll go for brackets iteration iter equals no iter equals 100 iter plus plus add on and put that bracket and then delete that off, delete the curly bracket with it. R new bracket, no if bracket R new is less than or equal to bailout brackets, curly brackets there, then we plot, the Mandelbrot set. Bailout is 5, make it 5. Save that update. Oh god. Unexpected token. Why is that? There's one bracket, curly bracket there, one curly bracket there, one curly bracket there, one curly bracket there. That's 4 curly brackets. There. Let's see, save update. One card. Cross. So please reload. Okay, we'll try from -10 to +10. -10 to +10. See if that works. Okay. Now that crashed too. Don't know why it's crashing. divided by 200, divided by 200. And we'll make that radius 0.5, that line length 0.5. It's looking a bit better. Okay. And we do XP from minus 500 to 500, and YP from minus 500 to positive 500. And we see if you divide it by 200, it's about 2 pixels size. Okay, run that. It's taking a lot of time, but there it is. Don't know what fractal it is. But it's not the Mandelbrot set, is it? Make it a bit bigger by dividing by 50. Divide by 50. Let's see. One curve. Oh, that didn't work. Maybe 100. 100. Oh, we multiply this by about 500. Multiply well by 500 on this line. Plot the point. Should be bigger now. I think this XOL equals CXS. That isn't a Mandelbrot set, is it? If we do XOL equals 0 to reset and wild equals 0. Let's see if one curve. Full screen. Divided by 200. CX and CY. I don't know what fractal it is. That's not the Mandelbrot set. What are we plotting here? Plotting. We're plotting XOLed and YOLed. It's an interesting fractal, but when to plot XP or CX and CY. So we go to this line, CX times 500, CY times 500, one curve. There it is. Mandelbrot set. Just have to edit that up. Multiply by, say, 200 rather than 500. There. and go to here, divide by 100, CX and CY to make it a bit smaller. There. That's a Mandelbrot set. Make a bit thicker line. Make a radius here of 1. Radius and line length 1. I'll put a comma there. 1 comma. There. That's Mandelbrot set.